Hello, grade 10s. Still continuing with analytical geometry. We're now going on to the gradient formula. Now, as I've printed this out, I'm just following the slides, guys. Now, the derivation for the gradient formula, I'm not interested in. Okay, you're not going to be asked this. Just following the slides. Okay, what I want you guys to get down in your books now is the heading gradient formula. And then you can copy all of this down. So let's have a look and see what's happening here. So the gradient, now the gradient of a line is the steepness of a line or the slope of a line. So if we go back to this previous slide over here, you can see that we have this straight line here and it has some type of a slope or gradient or steepness to it. And that is what we're going to calculate using this formula, okay, is the steepness of this line. So the gradient of the line joining 2 points where we have point A and it has an X value and a Y value, and point B where it has an X value and a Y value, can be determined by this formula here. Now, I want you guys to write down another one for me. It's exactly the same, it's just simplified. Now, it's small m equals y2 minus y1 over x2 minus x1. Okay, I would rather you guys use this one. All right, and what we say is it's just the changing y over the changing x. Okay, that's how we read it. So the order of subtraction in the numerator and the denominator must be the same. Okay, so what that means is you can see how I've got a 2, 2, 1, 1. I can't go 2, 1, 1, 2. Okay, it has to be like that. All right, so this is the formula that I want you guys to use. It's exactly the same as this one. It's just I don't want you guys getting confused and things like that. So that's how we're going to be doing it. Now, you can get this down for me. So a positive gradient, in other words, it's an increasing line where m is greater than 0. So that just means that your gradient is positive because it's bigger than 0. It goes in this direction. Okay, so if you have a positive gradient, your line goes like that. If you have a negative gradient, in other words, if your m is less than 0, your line is going to be going in that direction. So as we read from left to right, you can see as I'm going from left to right, this line is going up. So it has a positive gradient. As I read from left to right, you can see this line is going down. So it has a negative gradient. And this m thing over here is this, whatever we calculated here. And you'll see with examples just now that we get either a positive number or a negative number. Okay, for a 0 gradient, it's a horizontal line. So I need you guys to highlight horizontal line and then 0 gradient. Okay, so in other words, m is equal to 0. Your line is going to be flat like that. It's going to be a horizontal line. Okay, then an undefined gradient. It's a vertical line. So your line is going to be going like that, directly straight up and down like that. Okay, so those are the types of gradients that we get. We get a positive, a negative, a 0, and an undefined gradient. Okay, so if we have a look at example 1, it says here, calculate the gradients of the lines joining the following points and describe the slope of the line. So if I look at question A, now we have the 2 points here. So what I'm going to do is I'm going to say the gradient of PQ. Now this is subscript. PQ will be equal to. Now I want you guys to do it like this. Y2 minus Y1 over X2 minus X1. Now you're probably asking, well, what's this X2 and Y1 and all of this? Well, because this is our first point, remember with the coordinate, whatever coordinate it is, it always has an X value and then a Y value. So this is our X value, and because this is our first point, this would be X1. This here would be Y1 because it's an X, Y value. Okay, this is our second point, so this would be X2, Y2. All right. All I do now, guys, is I substitute these x1, y1, x2, y2 into this formula here. Okay, so what is our y2 value? It is 7. So that goes into that place there. Our y1 is also 7. Our x2 is minus 6. And our x1 is 3. And if we work this out on the calculator, because I know you guys are going to do that, we get 7 minus 7 over minus 6 minus 3, and we get 0. So the gradient of this PQ, the line joining PQ, is 0. Now remember, if you have a zero gradient, you have a horizontal line. So therefore this is horizontal. Okay, let's have a look at example B. I'm going to do it over here. So now we're looking at the gradient of AB. So little m subscript AB equals y2 minus y1 over x2 minus x1. Because this is our first point, this is going to be x1, y1. Our second point, x2, y2. And also grade 10s, notice how when I substitute, I always use brackets, okay? So our y2 is 0, our y1 is 5, our x2 is 2, and our x1 is minus 3. So we get the gradient of AB is equal to minus 1. Okay, now this is a negative number. Okay, I don't care what the number is just yet. Just the fact that it's negative, we are going to classify it with a negative gradient. So therefore it is a decreasing line. Okay, so therefore decreasing. All right. If we have a look at example C, we're looking for the gradient of EF. So that is y2 minus y1 over x2 minus x1. This is our first point, so this is x1, y1. Our second point, x2, y2. Okay, so our y2 value is minus 1. Our y1 value is minus 3. Then our x2 value is 3. And our x1 value is minus 2. We'll work this out on the calculator. And we get 2 over 5. EF. Now again, guys, I'm not too concerned about what the number is just yet. I'm just more concerned about if it's a positive or a negative number. Now, because this is a positive number, we know that a gradient that has a positive gradient is increasing. So therefore, this is increasing. Okay, guys, and it's as easy as that. So for homework, you guys can do exercise 11.4, number 1 for me, please. Thanks.